Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, this video is the continuation of our mini blender project in Solidworks. So previously I've shown you how we do part modeling of the lid and also the handle. So in this video we will do the other part, which is the mid plate. So this is a top view of the mid plate and this is the bottom view. If we study the shape, the geometrical shape of mid plate basically is a cylindrical plate, and they have kind of like features a cutout and a protruded cylinder here, and also the cutout, and they have kind of like a side wall here. And also if you look, this bottom view, and the top view is like this. So if we study the geometrical shape of this middle plate, the best approach to do the modeling in SolidWorks is we use boss revolve. So we know we must sketch the dimension of the cross section. If we could do this kind of, if you look, I already done that, the sketch of the cross section here. I already put the dimension. So the best way is we revolve it into revolve it on the center line. So as we see, I already measured the total plate diameter is 122. 122 is the total diameter. So the half portion of this, the radius is 61. So we need to draw this profile shape so that we could revolve it at the center line of 61 radius. Okay, so I already did the sketch here. The sketch will look, if you look on this image, this kind of sketch that we need to do. We must make sure that our sketch is fully defined. So let us do that in our SolidWorks file. So we open as usual the new part in SolidWorks. Make sure the unit is MMGS and the profile should be in the front plane. So I will draw the center line here. I draw the center line, then I will draw this kind of profile. So basically I will draw a line here. Make sure this one coincides with the origin point. I will draw this kind of shape. As basically, as long we have kind of like a rough shape of the profile that we need to revolve. So let me zoom in a little bit. This kind roughly, as long as we have the rough shape of it, this one's supposed to be okay. Let me escape here. I do the line here, need to be extended a bit here, and also the line like this, like that. And right, so okay, this is the rough shape. If you look in this image, okay, the 61 is the main diameter of the radius of the plate. So I will give a dimension of 61 here, 61, and if you look, the top one is, oh, hold on here, the dimension of the thickness. The dimension of this thickness is 3. It's thicker than the bottom one, and this one, the thickness is 2. Alright, and also if we look, we have a certain dimension that we have 5 units from here to here is 5, and where from here to here is 4. And as 4 is the, okay, from here to here is 5 units. and if you look here, the total height of this plate is 11. And let me drag a little bit this line, and the diameter here is 45. To explain you more to better understand, because this is the bottom view of the so we have kind of like this cutout here, and also if you look at the top view, they have kind of like extended cylinder here. So basically the shape is like this, so that's why our profile is kind of like this. We have a step up and we have a step down like this. So in my Solidworks, I complete dimension as shown in this image. So this will be 2. And also all the other thickness, this line and this line is also 2. And the diameter, if you look in this image, we have diameter 90 here. This, if you look in this image, so this one will be 45. So the dimension from here to the center line is 45. Alright, so that we can drag this a little bit here. And also if you look, the thickness from here to here is 2. Okay, the left portion of it we have already made fully defined. The only left is the right portion here is still okay. If since the hole is, if you look, the dimension of the hole is the diameter of the hole is 10, the middle hole. So our in here, from here to the center line should be 5. And also from here to here is 23, and the thickness here is, if you look in this image, the thickness at the top portion here is 1. This is 1 unit. We have kind of like a wall there, and also the also same is here, the level of this line, since we have 33, the level is measured from here to here is 5 units. So this line is fully defined, and also the thickness of from the level from this one to this level is 7 units. So for this, from this line to this line is 7. Okay, is 7. Then the only thing left, we still have blue color, is that since yes, the level from this to here is 1 unit, 1 millimeter. So I believe we have a fully defined profile. So okay, there is no conflict, everything is right. Then we will do under features here, we do revolve boss base, and we already selected, because the line, this is the axis of your revolution. So if I select the line here, so that will be the axis of revolution, and measure is 360 degree. So we have a basic shape of this middle plate. Alright, the next thing is that if we look in this photo of the top view, they have kind of like a little bit cut out here at the edge of the circular by a distance of 0.5, and the height of the cutout is 3 millimeters. So what I will do here, so this is a top view of the plate at this surface. So I will select the circular edge, then I convert to entities, and I change it to No, make it as a solid line. Then I will do an offset of 0.5, and I select these edges and make sure the direction is reversed inside. So this profile will be for me to cut extrude a little bit, extruded cut by the distance of 3. So we have kind like this form of geometrical shape as shown in this photo. They have kind of a little bit cut out at the edge. Alright, the next thing, if we zoom in this image, they also have an opening here, a gap here. Since just now we have made a cutout, we have made a cutout by 3mm deep, and they have kind of like have an opening here, and the opening, and we make another cutout. The angle from here to here is 12 degrees, and the depth of the cutout is about 2mm. So in Solidworks, in Solidworks we have another cutout from this plane. So I will select this plane, I make a sketch, so I create a center line from the center point up until make sure it's horizontal, and snap to quadrant. Then I will create another line up until this edge. Then I give a dimension of 6 degrees, since the total angle that for the opening is 12 degrees. So I will make a mirror, select this one and mirror about here. So I have a guideline for me to do the region for the opening. So I can change this one to construction geometry, and also I need to trace this edge. Okay, then I carefully select this edge and that edge, and we convert it to entities. Alright, so we have a guideline for us to trim. So I will trim this portion and also this portion. Okay, it looks like the line here is still construction geometry. Then alright, this line I convert it back to solid line, and also this line I convert it back to solid line. So we have a shaded region for us to do the cutout. So but we have lost the relation here. I must make sure that I set again the relation. This line and the center point here is coincident. We need to make it fully defined, and this line and this center point is coincident. So we have a fully defined shape. Then we do features, extruded cut. I will make sure the direction is downward and the cutout is 2mm. So we have an opening here. So since if you look in this image, the opening have 3 repeated pattern of the opening. Once here, the other 2 is at the back there. So we in Solidworks we will make a circular pattern. So I will do circular pattern, and the direction I can use this cylindrical surface and make sure the angle is 360 degrees. The number of 3 and features is the cutout. So we have a 3 repeated pattern of the opening, the cutout. Alright, the next thing to do, if you look again at this photo, if I zoom in, we have a features where we call snap features. This snap features, if the cross section of it is a triangle shape, so the triangle shape is kind of like a wedge shape. The cross section is triangle, so it start at this upper edge here and stop at this the plane of our cutout that we have just created. So I will do revolve boss base to do this snap features here. So in the angle is about 3 degrees. the total angle is 6 degrees, half of it is 3 degrees. So in Solidworks, so in order for me to do the wedge shape of the snap features, I will do revolve boss base. So the best plane to do that is on the right plane. So I will do right plane to do revolve boss base. So what I will do, since okay, before we go that better, we go for section view. Let's go for section view, but not on this front plane. We go for the right plane section view. So we have a better picture to do our snap features here. So on the right plane, I will create a sketch. So the wedge will be the wedge will be if you look again at this photo, the wedge start at the top edge and it stops somewhere close to this bottom cutout here. So I will do in Solidworks, I will do since we are in sketch mode, I will do triangle here. Start at this. Make sure that it start. Okay, I need to off the section view, so make sure that it's start at here and kind like this, and this is the shape of our snap features. Okay, the distance that I will set the distance from here to this plane is about go for 0.5, and the distance of this wedge, let's go for 2 millimeters. So we have kind of like, okay, let's reduce a little bit to 1.5. Okay, the thickness of these snap features. So I think, okay, that will be the profile of our snap features. Then what I will do, I will do features before that. Okay, I need to add a center line under this same sketch. I need on the sketch here, I need to create a center line to become as my axis of revolution of my revolve boss base. Okay, now I will do features revolve boss base, and okay, since they already selected the line is this center line, the axis, and but we are not doing for 360 degrees. As I mentioned, we go for let's go for let's try for 10. Okay, but if 10 we use it go to one direction, make sure that it's not blind. We use mid planes, it means it go for both direction. But if you look again in this photo, the degree, the angle is not too much, since the snap is not too long. So I need to reduce the angle by, let's say, go for 5 degree. Alright, 5 degree is about right. So this will be my snap features. Okay, this will be my snap features. Alright, then I click OK. Then what I will do circular pattern. Circular pattern, and direction is this cylindrical face, and 360 degree is the angle. The number is 3. Since we have 3 repeated pattern, if you look, these snap features have 3 of it. Okay, we have 3 repeated patterns, so we will do circular pattern. So features is this snap features, then the number of 3, so then we click OK. So then we have the snap features of our middle plate. Alright, okay, the next move is, if we look in this photo, if I zoom in of this middle plate, we have features here which is a kind of like a shape of a slot. There's another view I can show you, direct normal view of it, but the picture is not that clear. So we have kind of this shape of a slot. The features of this slot is it acts like for a locking mechanism to the bottom container. Later I will show you how we model the container, the bottle container. They have a small shaft that will be passed through this slot to act as a locking mechanism for the middle plate to the container. So this slot have 3 pattern also at the back there. The shape of the slot I already show you. I already make a sketch of it. So this rough shape of the slot, I already put the dimension. The total slot length is 35 and the height is 5, and the distance from the end of the slot to the snap features that we have just created is 13. So this is basically the dimension. So it means in Solidworks I have to create this profile of the slot. Alright, but in Solidworks I will just need to explain to you to do this, because the slot will be somewhere at the bottom here. To do this slot, I will not use create the profile of the slot and use direct projection method to the surface, because it will not be accurate. The accurate way to do this is to use, okay, please take note on this. The command is a wrap command. Under feature insert features, we have a command called wrap. Okay, wrap command, wrap means that we create the slot shape, and it will wrap around this cylindrical surface. So I draw the pattern shape, the slot shape. So I need to, because when we say is wrapping, we need to know, because this is cylindrical surface, I have to create the circumference, the rectangle. When we unwrap cylindrical surface, it becomes a long rectangle, so that the length of the rectangle is the circumference of this cylindrical surface. Since we know the diameter of the cylindrical surface is 122, so I have to create a rectangle with the length of pi times the diameter is 122. So I get a value, so that will be the total circumference of this cylindrical surface. Then under that's rectangle, that I for the total length of the circumference plus the height of the cylindrical surface, and then I will draw my profile of the slot on that rectangle, and then the profile that I just created on that rectangle will be wrapped around the cylindrical surface. I hope you understand what I'm trying to tell you. That's the good thing about using wrap. Okay, to do wrap, since we need our wrap will be around the cylindrical surface. Okay, to do that, I need to do the wrap on the front plane. Okay, need to do the wrap on the front plane. So I will draw a rectangle anywhere around here. Create rectangle. The length of the rectangle, if I give the dimension, the length of this rectangle is the total circumference of the cylinder, pi times 122. So I will do, if you hold it, I go for a calculator here. So we know the diameter of the cylindrical surface is 122 times the pi. So this will be the circumference of that cylinder. So select everything here and you copy. So this one will be, when I give dimension, just paste it, the value. So this will be the total length of the circumference. And also, if you look again, the height of the sketch profile is 5, so it means the height of our rectangle is 5 units. So this will be the total. It's a boundary for me to wrap around this cylindrical surface. Alright, so I need to convert all this line into construction geometry, because that will be our boundary. Okay, another thing to do, we need to position this wrap. Okay, for in Solidworks to do wrap command, you need to position this boundary of our wrap at the middle of our cylindrical surface. So I select the bottom line here, select midpoint, and I click at the origin point and make it coincident. So it will be it will be put at the center of this cylinder. Okay, then I will create a profile shape here, as I already sketched the dimension. Simply draw a straight segment of it. So okay, let's do that and create that sketch. So what I will do, so I just draw the line, okay, somewhere around here, and we have this kind of shape like this, and I stop it there and stop at this boundary, something like this, and stop it here. So now we put the dimension. If you look, the dimension is here is 10, and I give a dimension. Here is 10. Let me go for dimension. Here is 10, and also stated here is that 5 is the height. All right, 5 is the height. Okay, because since it's already at this borderline, so I don't need to give the height of it. So what I need to do to give the distance from this edge to the snap hook here, we have just created the snap features here. The distance from the snap features to the edge of this is 13. Then I give the dimension from here to this edge of this snap features is 13. Okay, another thing is the thickness of the slot is 2. The thickness of the slot is 2. So from, okay, I just give the dimension here is 2. Okay, now we still need another dimension to make it fully defined. The total length is from here to here is 35. The total length of the slot is 35. So from this edge to this edge is 35. So now our profile of our slot is fully defined, but I don't have to do the curvature there, because I will do it later when after I make a cutout of the slot, after I do wrap command. So this is our basic profile of the slot. So okay, we make a slot, then we will do a circular pattern to repeat our slot cutting on the surface. So I just do the pattern once only. So now I have the profile of the slot to be wrapped around the cylindrical surface. So then I zip my sketch. So make sure that, okay, we use insert to do wrap is insert. Okay, take note of these features, and we use wrap. Okay, wrap, then you select the sketch, that profile that we just created, and okay, under this wrap, okay, if you look on the wrap setting, the first option is what we call it emboss. This is the emboss. The first is emboss. Emboss, it means, well, the slot will be wrapped here, but it will not make a cutout. It will extrude it outward. So our case here is that we need to make a cutout. So we will do deboss, cutout inside. So what we will do, deboss. So we will use the middle option, which is deboss. Make sure this one, the wrap is the first one is cylindrical wrap, and the sketch is already selected just now. And this, okay, this features is what surface, cylindrical surface that you want to wrap. So we will use this surface to be wrapped around. Okay, this one setting is how deep that we want to either emboss or deboss. In our case, we will do deboss. So let's go the thickness of 1. Then I click OK. So we have a slot have been wrapped around the cylindrical surface. Later I can do fillet. Since the thickness here is 2, I can do fillet of radius 1. Fillet of radius 1 to these 2 edges to make it round. Okay, and also since the thickness here is 5, so I will do fillet of radius 5 to these edges, and the distance here is 3, so this one fillet radius 3 to these edges. So we have the shape of our slot as shown in this photo. Right? Okay. So now after I create one profile of the slot, then I can use circular pattern. Okay, under this direction I can use the cylindrical surface. Alright, the degree is 360 degree, and the number of circular pattern this slot, as I mentioned before, we have 3 pattern of the slot, and circular pattern 3 of it. So I will do number of 3. Okay, under features here, make sure I clear everything. Just we select all the features, the slot and all the fillet that we have just created, so we can use this. listing here. First, we'll select the wrap. The second, we select this fillet 5, and also fillet 6. Fillet 6. Alright, so everything is there. Then we click OK. So what you will do, you will repeat the pattern of 3 slots. So we have the features of our slot. Alright, okay, the last thing to do for this mid plate, we have extruded protruded cylinder at the center of this middle plate. So in this plane, I will create. Okay, I can simply select these edges, convert to entities, and then I will do offset of distance 1 outside. Click OK. Then I will do extrude just 1 unit. Extrude 1 unit. So we have a protruded cylinder. Right. Let me check. I think yeah, I think that's all for the middle plate. Alhamdulillah, we have completed the part modeling of the middle plate of the container. So inshallah, I will do the next video for the bottle container of this mini blender. Okay, inshallah, I will see you soon in the next video. Okay, Assalamualaikum warahmatullahi wabarakatuh.